Hello friends, welcome back. In previous few videos we have seen the first type of isomerism, that is the structural isomerism. In this video we are going to start with the second type of isomerism, that is the stereoisomerism. The stereoisomerism is also known as the space isomerism. So let's start with the stereoisomerism. What is stereoisomerism? The two complex compounds which are having the same ligands, and the same ligands are coordinated to the same central metal atom or the ion. But when the arrangements of the ligand in space is different, then such complex compounds, they are called as the stereoisomers of each other, and the phenomena is known as the stereoisomerism or the space isomerism. That means we can say that we are having two complex compounds, they are having the same ligands and which are coordinated to the same central metal atom or the ion. But when the arrangements of the ligands in space, or we can say the around the central metal atom or the ion is different, then they are forming the stereoisomers, right? Then the types we have also seen in the previous videos. There are two types of the stereoisomerism. The first one is the geometrical isomerism, or which is also known as the cis-trans isomerism or position isomerism. This is the first type, whereas the second type is the optical isomerism or mirror image isomerism. So we have to study these two types of the stereoisomerism. So the first one is the geometrical or cis-trans or the position isomerism. So what is the meaning of this isomerism? This type of isomerism arises due to the difference in the arrangement of groups, or we can say the ligands around the central metal atom or ion, which is known as the geometrical isomerism. Now, as given in the title, it is also known as the cis-trans isomerism or position isomerism. What do you mean by cis-isomer? Cis-isomer means when the similar or the same ligands are present on the same side of the metal. On the other hand, trans-isomer means when the same ligands are present on the opposite side of the metal. So in this isomerism, we have to find out the cis-isomer and the trans-isomer. Now, this isomerism is not possible with the coordination number 2 as well as the 3. And it is also not possible for tetrahedral complexes with coordination number 4. We know that for the coordination number 4, two geometries are possible. One is the tetrahedral and the second one is the square planar. Now here the cis-trans isomerism is not possible only for the tetrahedral complexes, whereas it is possible for the square planar complexes. Now why it is not possible for the tetrahedral complexes? Because for tetrahedral complexes, all the four positions are adjacent to each other, right? So as the positions are adjacent, we can't distinguish the cis-isomer and the trans-isomer. Therefore, it is not possible for tetrahedral complexes. So we can say that this isomerism is possible only for 4 coordinate square planar complexes and 6 coordinate octahedral complexes. So we have to find out the geometrical isomerism for square planar complexes as well as the octahedral complexes, right? So these are the types for the geometrical isomerism: square planar complexes and the octahedral complexes. So the first one, the geometrical isomerism in square planar complexes. So geometrical isomerism shown by the square planar complexes are of following types. There are total 5 types which shows the geometrical isomerism in square planar complexes. The first type is Ma2B2. Right? What is M? M is the central metal atom or the ion, and A and B are the coordinating groups, or we can say the ligands. This is the first type. The second type is Ma2BC. Third type MABCD. The fourth type is MAB twice. And the last, that is the fifth type, is M2A2X4. So these are the 5 types of geometrical isomerism which are possible in the square planar complexes. In all these types, M is the central metal atom or the ion, and the A, B, C, D, these are the ligands or the different ligands which are coordinated to the central metal atom or the ions. So we have to study all the 5 types. So let's start with the first one. The first type is the Ma2B2. Okay. So what is the M? M is the central metal atom or the ion, right? A and B. What are these A and B? These are the two monodentate ligands. Remember, A and B are the monodentate ligand. Let's see the example of this type Ma2B2. Its example is PT NH3 twice Cl2 2 plus. Right. Now here A is the suppose NH3 and B is chlorine. They are 2 in number. So the example is PT, that is the central metal atom, NH3 twice Cl2 having the charge plus 2. Let's see the structure. Now here we have to find out the cis isomer and the trans isomer, right? Cis isomer means the similar groups or the same ligand, they are towards the same side of the metal, whereas a trans isomer, the similar groups, they are towards the opposite side of the central metal atom or the ion. So the first structure. So this is the first structure. In this structure, the central metal atom is the platinum, right? And this platinum is attached to 2 NH3 and 2 chlorine. Now these 2 NH3 and the 2 chlorines, they are towards the same side. So it is called as a cis isomer and its name is cis dichlorodiamine platinum plus 2 ion. Whereas the second isomer is again platinum central metal atom and there is an arrangement of 2 NH3 and 2 chlorine. Now here we can see that the two similar groups, either this NH3 or the chlorine, they are towards the opposite side of the central metal atom or the ion. That's why it is called as a trans isomer. And its name is trans dichlorodiamine platinum plus 2 ion. So in this way we are having the cis isomer and the trans isomer. Second type is the Ma2BC. Okay, now here this ABC indicates that there are 3 ligands. So here we can say that M is the central metal atom or the ion. Suppose a platinum, for example platinum metal. Small a is the neutral ligand. Here small a is the neutral ligand such as NH3, pyridine, etc. And the third one, B and C. B and C, they are the anionic ligand, or we can say the negative ligands such as chloride, bromide, iodide, SCN minus, NO2 minus, etc. Then cis isomer. How we can find out the cis isomer? When the similar groups are here only A. The B and C are there different. Therefore, when A, they are towards the same side, it is called as the cis isomer. Whereas the trans isomer means this A, they are towards the opposite side, therefore it is called as the trans isomer. So in this way, when the similar groups, they are towards the same side, it is called as the cis isomer, and when it is towards the opposite side, it is called as the trans isomer. So let's move on. The example of the type Ma2BC. Its example is platinum PT, that is NH3 twice Cl Br2 plus. Now from this structure we can say that when the same, that is the NH3 are towards the same side, it will be termed as a cis, and when it will be towards the opposite side, it will be termed as a trans. So let's see the structure. In this structure, the platinum, that is a central metal atom, it is attached to 2 NH3 which are towards the same side, right? So it will be a cis isomer, whereas in the second isomer, the NH3, they are towards the opposite side, therefore it will be termed as the trans isomer. So in this way we are having the cis isomer and the trans isomer. Third type is the MABCD. That means here there are 4 types of ligands. So complexes of this type shows 3 isomers. This can be written by fixing one of the ligands, suppose A, at one position and then placing the ligands B, C, D trans to it. So let's see this. Suppose if we are having, this is the first structure. We are having the square planar complex. At the center we are having the metal and it is attached to the 4 ligands A, B, C and D. Right. So we have to draw 3 isomers are possible. Okay. So how to draw these 3 isomers? We have to just fix the position of any one ligand. Suppose this A is fixed, and across the A we are having the B, C and D. Suppose this is the first isomer. Then we are having the second isomer. Again we have fixed the A, right? Then we are just carry out the interchange between C and D. Just C and D. So we are just interchange the position of C and D, whereas this A and B, they are kept as it is. And the third isomer. Again the A having the same position. Then we are change the positions of the C and B. So C and B, they are interchanged. So we are getting the 3 isomer. So in this way there are 3 isomers possible for the type M, A, B, C, D. So let's take an example. Example is the PT-NH3, C5H5 and ClBr. That means this platinum is attached to 4 different ligands. So 3 isomers are possible. The first isomer, we are having the platinum at the center and it is attached to NH3, then NC5H5, chlorine and bromine. This is the first isomer. Now in this first isomer we have to fix any one ligand as A. That means its position will be fixed. So based upon this we are having the second. So suppose this NH3 is A. So this NH3 remains as it is. This NC5H5 it is B. Then we have just carry out the interchange between the bromine and chlorine. So chlorine comes here and bromine is over here, right? And then based upon this we are having the third structure. Again NH3 as it is. Then we have carried out the interchange between the chlorine and NC5H5. So chlorine goes over here and NC5H5 over here. So in this way these are the 3 isomers possible for the type M, A, B, C, D. Let's take one more example. Next example is the PT-NH3NO2ClBr+. Again platinum is a central metal ion which is attached to 4 different ligands. So 3 isomers are possible. The first isomer is platinum at the center which is attached to NH3, then NO2, Cl and Br. Okay. Then the second isomer. Again we have to just fix any one. Now here we are just suppose fix NO2. NO2 over here, chlorine over here. Then we have carried out the interchange between the NH3 and the Br. So Br comes over here and NH3 over here. We have fixed the position of NO2 and the Cl. NO2 and the Cl there remains as it is. Then the third isomer will be, what is the third isomer? Then we have keep this chlorine. This chlorine will be suppose A. In each case this is A, this one is A, therefore this one is also A. So in the third isomer we have carried out the interchange between this NH3 and the NO2. So we are getting the third isomer. So in this way there are 3 isomers possible for the type M, A, B, C, D. Let's take the next type, that is the fourth type, which is M, A, B twice. Now here again M is the central metal atom or the ion and AB. There are 2 AB and AB is the unsymmetrical bidentate ligand. Unsymmetrical bidentate ligand, that is the ligands with 2 different coordinating groups. That means we are having a single ligands and which is having the 2 different coordinating groups. In this, the cis isomer means, now suppose this is the arrangement. We are having at the center M and it is attached to 2A and 2B, right? Now when the 2A or 2B they are towards the same side, it will be considered as a cis. On the other hand, the 2A or the 2B towards the opposite side, it will be considered as a trans. So in this way we have to find out the cis isomer and the trans isomer. So example, its example is a PT, that is a platinum GLY. GLY means a glycine atom twice. So what is this GLY? GLY is the glycine atom and its structure is NH2, CH2, C double bond O, O, right? So we are having the structure of the PTGLY twice. That means platinum at the center and it is attached to 2 glycine atom structures. Now in these structures, either these 2 oxygens or these 2 NH2, they are towards the same side. Okay. So it will be termed as a cis. Whereas we are having the second isomer in which the glycine atom structures, at one side we are having the NH2 and other side oxygen, or the same groups NH2 and the NH2 or oxygen and oxygen, they are towards the opposite side, hence it is termed as a trans. So in this way it is a cis isomer and a trans isomer. Let's take one more example. It is Cu, that is copper glycinated twice. Now this is a cis isomer. This is structure of Cu, that is a copper at the center, and it is attached to two glycinated structures. It is called as a cis isomer. How it is cis isomer then? Cis isomer means when the similar groups are towards the same side of the central metal atom or the ion. Now here, instead of the groups, here we have to consider the atoms, right? So the atoms, in this case cis and the trans, the atoms are oxygen. The first oxygen and the second oxygen. These two oxygen, they are towards the same side. Or instead of oxygen, we may consider the two nitrogens. If either oxygen or nitrogen are towards the same side, it will be termed as the cis. Whereas in the second isomer, the oxygens, the two oxygens, or we may say the two nitrogens, they are towards the opposite side. Therefore, it is termed as a trans isomer. So instead of considering the groups, here we have to consider the atoms, and when the same atoms they are towards the same side, it will be a cis isomer, and when the same atoms they are towards the opposite side, it will be considered as a trans isomer. Then the last type, that is M2A2X4. Now this type shows the geometrical isomerism in bridge binuclear planar complexes. So the bridge complexes shows this type of isomerism. M2 means there are two metal atoms. So this is the first metal atom, this is the second metal atom, and it is attached to 4 ligands, that is X. These are the 4 ligands, and then it is attached to 2 A ligands. Now it is called as a cis isomer. Why it is called as a cis isomer? Because the 2A, they are towards the same side of the two metals. Whereas the second isomer is the in which the 2A, that is a similar ligands, they are towards the opposite side of the metal atoms. So in this way, we have to find out the cis isomer and the trans isomer. So let's take an example of this type. Example is a PT, that is a platinum Cl2 PET thrice, and this is 2 times. So its structure is, we are having the 2 platinum. These 2 platina, they are attached to 4 chlorines. So this is the first, second, third, and the fourth, and then it is attached to 2 PET thrice. Now when this PET thrice, they are towards the same side, it will be considered as a cis isomer. Whereas when the this PET thrice, they are towards the opposite side, it will be considered as a trans isomer. So in this way, when the two ligands, the similar ligands, they are towards the same side, it will be a cis isomer. When they are towards the opposite side, it will be considered as a trans isomer. So this is regarding the first type of isomerism of the geometrical isomerism. In the next video, we are going to study the next type of the isomerism, that is the optical or the optical isomerism.